So arguably one of the most important skills that you will need to have down really well for this course is the ability to draw in 3 dimensions. Okay, this entire course will be 3 times easier than any of the calculus courses you have ever taken, as long as you know how to sketch things in 3 dimensions. Okay, and so this is kind of a review of techniques that we use to sketch things in 3 dimensions, and it usually stems from this idea of being able to draw what we call traces of a function. Okay, and so a couple things to remember when doing this. So, for example, let's say that we have some 3D shape, and it's given by x squared plus 2y squared plus z squared is equal to 4, we'll say, okay? And the goal here is to, we want to sketch this. Sketch this shape. Like, what is it? Okay? And let's pretend that we don't remember anything from Calculus 3. Okay, and so we could try and just draw, here's our axes. We could try and just do this and plot random points and just there one here, 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 here. But to be honest, this is a very impractical way of going about this. And we learned about this technique of drawing what we call the traces of a function. So as a reminder, it is a really good tool to have to basically create 3 axes. Right, three sets of coordinates, and these are going to serve as the basis for our traces. So one of these is going to be x and y, one of these is going to be x and z, and one of these is going to be y and z. And basically what this represents is, what would we be seeing in 3 dimensions if we turned our view to the side, right? Because technically our axes exist in 3 dimensions, right? Just like I had previously sketched, x, y, and z. But we want to say, what is this shape going to look like if we just look at a slice of it, right? So let's pretend, I believe this shape is going to be an ellipsoid, but let's just pretend that it was a paraboloid or something like this, okay? And so the question is, if I were to look at it, say, only in the x and y direction, right? What if we were to just take a slice of it? What shape would we see? Well, hopefully, we'd probably see some sort of, let's actually sketch this a little more accurately. We'd probably see something that looks a little bit like this if we were to take a slice of it, right? And, we could do the same thing if we wanted to look at it in the xz direction. So maybe we let y equal 0. And if we let y equal 0, what are we going to see? Well, we're going to see something like this. If we take a slice in this direction like so, right, what would we see? Well, we'd see probably something pretty similar, right? We'd probably see something that looks like this, okay? And the whole point is that we're going to use this just like a camera system, on Teslas. That's how they figure out what kind of objects are around them. They take all these 2D images and they compile them into one 3D object. So the way that we typically do this, one of the easiest ways is to look at, when is one of these variables equal to 0, right? That means we've taken our view of this and we're turning it to the side and saying, what do we get? So for instance, if we are looking at the case when z is 0, then we are going to be dealing with the drawing x squared plus 2y squared equals 4. Okay. If we're looking at y equals 0, then we're going to be looking at x squared plus z squared equals 4. Okay, and if we look at when x is 0, we get 2y squared plus z squared equals 4, like so. And you're like, well, am I supposed to know how to draw these? Absolutely you are. This is essentially things that you need to know how to draw. You need to know, what does an ellipse look like? You absolutely need to know what a hyperbola looks like. We need to know how to draw a circle, right? What is the equation of a circle? What is the equation of a parabola, right? These, I would say, are some of the fundamentals. Also, the equation of a straight line, right? We should be experts working with lines. Eventually, we'll learn planes and stuff. But, for now, these are the shapes that I would say you should be very good at in this class. So, let's start with the easiest one, which is actually going to be this guy over here, right? X squared plus z squared equals 4. That's just a circle centered at the origin of radius 2. And so we could sketch something that kind of looks just like that, right? There's a circle, radius 2, and it goes out, to the point 2, 0 here, and the point 0, 2 here, right? It's a circle, radius 2. The other ones are ellipses. How do I know? Because there's this distortion factor of 2. They almost look like circles, but they're a little bit wider in certain directions. And so this might not look like an ellipse exactly, because technically the form of an ellipse would be something like this, where we have x squared over 4 plus y squared over 2 is equal to 1, right? Where this thing on the right side here is equal to 1. And there are many formulas available for you to recognize exactly, what does the number 4 mean? What does the number 2 mean? Which one is our minor axis? Which one is our major axis? Things of that nature. But the idea here being that, well, I guess I can leave this for us actually. The idea here being that this is going to be a parabola, and it's going to stretch a distance of 2 in the x direction and a distance of square root of 2 in the y direction. So it's going to be something like this. And it's going to have, 2, 0, and square root 2, or 0, square root 2, right here. And you're like, Dylan, how do you know that? Well, I'm a genius, right? No, you can pull up any sort of tool that you want. So use equations until you get the hang of it and you can do it in your head. Use equations to help you. Okay. You can use Desmos to help you if you really need to. But the idea here is that we want to kind of follow this process for all of these. And so for this one here, this would become y squared over 2 plus z squared over 4 is equal to 1. And this, again, is going to be very similar, where we're going to go z stretches in the direction of 2 now, and the y direction still in square root of 2. So this is going to be the point square root 2, 0, and this is the point 0, 2. And we're going to use these to make an educated guess about what our shape looks like, right? And this is super important because when you're trying to evaluate double integrals, or later on in this class, triple integrals, or however many integrals that we're dealing with, we really need to have a good understanding of what does this shape look like. Now, I agree. You could just take this and you could plot this into Desmos. Totally understand. And you can do that, and go ahead and do that if it helps you. But I'm just saying that if you have this skill under your belt, what this will actually do in the future is it allows us to come up with regions of integration very easily. So if you've already watched a video that covers what I mean when I say that we're integrating over a certain region, being able to look at the trace of a shape, of an object, allows you to kind of visually see how far in the y direction do we need to go, how far in the x direction do we need to go when we're coming up with bounds. It also lets us do it, how far in the z direction do I need to go, right? It allows us to do wonderful little tricks like this. And so, what does this shape look like? Here's x, here's y, here's z. So I got to think about this for a second. So for me, I'm looking at this one. I know that if I look at the xz axis, I'm going to see this kind of circular shape kind of going this direction. Okay, that's me looking dead on to the xz axis. If I look at the xy axis, so from the top down, let's see, we go not as far. We're going to get this ellipse, right? That's kind of what we came up with, like so. And then if we do it in the z direction, if we do it in the z direction, I probably should use a different color. So let me highlight this green just so we know what we're doing. In the z direction, we go up to 2, but we still only go out to that to the square root of 2 that we're bounded by y. And so this very roughly is our shape, right? It looks like we're going to have this ellipsoid, right? It's an ellipsoid. It's circular on one side. It's kind of, ellipsoidal if we look at it in the other direction. And, we could use Desmos or use, I guess, since we're in 3D, GeoGebra. Oops, can I spell? GeoGebra 3D to verify the shape. Okay. But again, I would like to stress to you all, this is super important because later on in this class, we'll be discussing, what does it look like when two shapes intersect? What is going to be the region of integration that exists underneath this shape, right? AKA, like, what shadow does this shape cast onto the XY axis? And it's a lot easier to answer that question if you've already done the trace, because then once you know the trace, you'll be able to figure out, it just goes up to this in the X direction and this in the Y direction. And we can actually use this equation right here to come up with oftentimes our regions of integration for more complicated problems. So this again is only one worked out example. This is a review topic from Calculus 3. So I would suggest if you want some more help with this, you don't remember, you can check out 12.6 in the textbook, where it kind of goes through how to do these. I believe also, let me just double check really quick, in 14.1, it also talks about drawing level curves and things like that, which you can check out as well. But basically just helps inform us what our shape is going to look like. So check this out, get some practice. Don't just watch this video and be like, oh yeah, okay, I'm good. You should try to do a couple examples from 12.6 or something and check your answer on GeoGebra. Okay, and you can use the tool for GeoGebra where you grab like this axis and you turn it so that you're only looking at the X and the Z axis, and you're gonna see hopefully that, oh yeah, okay, the shape that we came up with looking in the XZ direction was in fact this circle, and so on and so forth. So you should use that tool to kind of look to the left, look to the right, look down at it, and just be like, oh yeah, okay, this matches what I got for the traces. All right, so hopefully this is helpful, and feel free to check out the other videos, and I'll see you in the next one.